Ismail is here. Today we are going to learn 2.1, which is the new chapter, power and radical functions. In some pre-calculus edition books, chapter 2 it's talking about logarithmic functions and exponential one. But in the version that I have here, it's different. The logarithmic and exponential function in chapter 3. So in chapter 2 we're talking about polynomials, power radicals and functions. Now let's start here about the chapter 2.1 power and radical function. What we are going to learn there, we're going to learn two things. We are going to learn how we graph and analyze the power function, and how we graph analyze radical function. Then we need to know how to solve the radical function. Okay, now from its name it's saying power function. Power functions mean any function has a power, which means x to the power of 2, x to the power of 3, x to the power of 4. So it's written like this. So x to the power of 2, x to the power of 3, x to the power of 4, x to the power of 5. So all of these is considered as a power function. What's the difference between these functions? I just explained them before. I mean, let's take now x to the power of 2, x to the power of 4, x to the power of 6, okay, x to the power of 8, okay. So all of these function, okay, all of these power function is let's say they have the same power, which is power is even. As you can see, when I have an even power, okay, so even power, it's always the graph, it's look like a parabola, always starts up, ends up, starts up, ends up. All of these function are a parabola. Always when the power is even number, it's a parabola. Now how about if the power is odd, like x to the power of 3, x to the power of 5, x to the power of 7, sorry, x to the power of 9. So all of these function is a cubic function. You know that a cubic function starts from down, ends up, starts down, ends up, starts down, ends up. So this is the difference when the power is even and when the power is odd. So now if we need to extract a function between this one, I can extract that the function is f of x is equal x to the power of n. So this is the rule for the power function. X is to the power of any number, and n can be even, okay, and n can be odd. The difference between them is the graph. Now how about if I have a, means the leading coefficient. A here considered as a leading coefficient when A is positive and when A is negative. So example, let's say I have negative x, so the graph will be downward. If I have negative, the graph will be downward. So all of these, when I have a negative, the graph will be downward. How about if we're talking about this one? So this one, if rather than starting down, ending up, so it will start from up and goes down, starts up and ends down, starts up, ends down. So this is the difference between the odd function and the even function. Okay, so we can extract the formula, which is written here. F of x equal ax a times x to the power of 2 to the power of n. Okay, so now to analyze the function, as you can see the domain from left to right, so from left negative infinity to positive infinity, the range from the lowest point to the highest point, which is from the 0 to infinity. The x-intercept is 0, 0. The end behavior is continuous at all functions, and as you can see this one is symmetrical over what axis? Okay, it's over the y-axis, means anything on the right, same anything on the left, so it reflects symmetry over the y-axis. Okay, so the same thing here when it's negative, but the domain, the range here will be different because it starts from down from negative infinity to 0. Okay, so this is what you can see for when n here, when the power, sorry, let me erase it. So here when n the power is even. Okay, now when the power is odd, as I told you, it's a start when n, which is the power, is odd. So as you can see, starts down, then goes up, and when it's negative, okay, it starts up and down. Okay, now let's take examples about what we learned. Now let's analyze the monomial function. So as you can see here, what is the power given in the function here? The power is what? Is 4. So that's mean n is even. And when n is even, the graph should be a parabola. As you can see in the blue color here, the graph is a parabola. If you need to find the exact value, you just make the table, put in the middle of your table 0, 0, pick 2 or 3 points greater than 0, pick 2 or 3 points less than 0, then you can plug in the values in the function, then you can find it. Now you know how to identify the domain, which is from negative infinity to positive infinity, the range, intercept, and all of these information is easy to you. Okay? Now, another one here. Analyze monomial function. As you can see, look to the power. The power here is odd. N is odd function. Odd function is start down and up. Okay, sorry, it's not like this. So it starts down and up. So this is the odd function, right? Now, look to the leading coefficient A. A is positive or negative? A is negative, so it will start up and down. So now it will be start going up here, and from here it's going down. So this is the graph of negative x to the power of 7. Now if I need to analyze the graph, let's find the domain. So the domain is from left to right, from negative infinity to positive infinity. Now the range from down to up, same thing, from negative infinity to positive infinity. Now what is the end behavior? So when limit f of x, when x approach negative infinity, the graph goes up or down. Negative infinity, the graph goes up, so it's positive. Now when limit f of x, when x approach positive infinity, so this positive infinity, so the graph is going down, so it's negative infinity. Do I have intercept? So the intercept is 0. 0 is the intercept. Is there any discontinuous, removable, infinite jump? No, so it's continuous at all function. And is this one increasing or decreasing function? So start from left. Left it was up, okay, and then it goes down, 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 still goes down forever. So it's decreasing function from negative infinity to positive infinity. It's decreasing function. I hope you understand this. Now let's take one more example here. 3x to the power of negative 2. Okay, now before we look to this example, let me explain to you when I have the same power but with a negative. It means, you know that we can have negative x to the power of negative 2, x to the power of negative 3, x to the power of negative 4. So all of these also considered as a power function. Okay, so all of these as a power function. But as you can see, the power here is negative. And you know that there is a rule, okay, when you have a negative, the rule said when I have a negative exponent, I can rewrite the quotient as 1 over x to the power of n. So this rule, you have to memorize it. So I can rewrite every one of these, okay, as exponential, as a fraction. 1 over x to the power of 2, 1 over x to the power of 3, 1 over x to the power of 4, 1 over x to the power of 5. So as you can see, what type of function is this? So all of these considered as a reciprocal function or rational function. So what is the rational or reciprocal function? If you remember from what we learned before, when I have 1 over x to the power of 2, 1 over x to the power of 4, 1 over x to the power of 6, or let's say x to the power negative 2, x to the power negative 4, x to the power of negative 6. So how the graph for this will look like? So the graph of this, it will be like this one here. So this is y, this is x. So the graph will be something like this. So the graph for the even power, okay, so as you can see, always it should be like this. When the power is negative even, so the graph should be always like this one here. Now, when the power is, let's say, x to the power x to the power negative 1, x to the power of negative 3, x to the power of negative 5. So this one means 1 over x, 1 over x to the power 3, 1 over x to the power of 5. So now if I need to graph this function, the function will be in quadrant 1 and quadrant 3. Same thing here for the other one, in quadrant 1 and in quadrant 3. The same thing here for in the quadrant 1 and in quadrant 3. Okay, so now always the graph, when it's odd number, okay, it will be in quadrant 1 and quadrant 3, because you know that this side here is quadrant 1, this side here is quadrant 3, this is quadrant 1, this is quadrant 3. Okay, so and when it's even power, it should be in a quadrant 1 and a quadrant 2. So this is a quadrant 1, this is a quadrant 2. Quadrant 1, quadrant 2. Okay, I hope you understand. So now let's write this formula here. So when n, okay, even, okay, but negative, okay, but negative number, so the graph will be like this, okay. When n is odd but negative, okay, so the graph will be in quadrant 1 and quadrant 3, okay. So keep these in your mind. Now look to the function here. The function is saying graph analyze the function. Look to the power. The power is odd, okay, and negative. So that means this function is 3x to the power of 2. So we know that when it's even, so the graph should always look like this one here. Okay, so this is what you can see in this graph. It starts like this, ends like this. Now if I need to analyze the function, let's identify the domain and the range. Okay, so you know that if I put what's the excluded value from the denominator, the excluded value is 0, because if I have a 3 over 0, it's equal, does not exist. So 0 is undefined, so I need to identify the domain from negative infinity to 0, union from 0 to positive infinity, because 0 is excluded value. Now how about the range? The range from the lowest point, so as you can see, the lowest point on the graph is this one. So from 0 to goes where up forever, so to positive infinity. Okay, now the limit in behavior, always the okay, let me tell you, always the in behavior for the reciprocal function, it's always approaching 0. When it's positive, it's approaching 0. When it's negative, approach negative, also still 0. Always like this, because 0, it will be does not exist. So that's why the function always will close or approach to the 0 value. Okay, and as you can see, the function is increasing from negative infinity to 0, because start from left, it start down and goes up. So this one is increasing part. Okay, and then complete, it starts up and goes down, so that means this part here is decreasing, which is from 0 to positive infinity. Okay, I think now you understand the concept, so let's do this one very fast. Okay, as you can see here, x to the power of what? X to the power of negative 5. So the power here is odd and it's negative, so it should be 3 over 4, okay, 1 over x to the power of 5. Okay, don't forget 3 over 4 is negative. Now 1 over x to the power of 5, it's in quadrant 1 and in quadrant 3. But now look to the a. A here is negative, right? So you have to flip this one over the x-axis. So this one here will go here and this one here will go here. So the function should be, okay, let's say I have this one. So the function will be like this one here, and this one in quadrant 2 and in quadrant 3. So the function, of course, will be like this one, because a is negative. If a is not negative, so the graph will be going in quadrant 1 and quadrant 3. Okay, don't forget, always look to the a after you identify the power. Okay, now what is the domain for the function? So the domain from negative infinity to what value? Union to that value to positive infinity. How can I identify the values? To identify the values, look, what's the number make the denominator equal 0? So x is equal 0, okay, when x cannot be equal 0, because when x equals 0, it's excluded. So I have to write 0. So always the excluded value is the domain. Now the range, start down, ends up. So same thing. What is the thing that's always equal to excluded value? So always 0, because if you start down and the function stops at what value? It's stop at 0. Then from 0 it's completing up. So from negative infinity to 0, union 0 to positive infinity. Now what is the end behavior? I told you always, let's say most likely when it's talking about the end behavior for the reciprocal function, always approaching 0 from the left and always approaching 0 from the right. Okay, the increasing, decreasing. So the first function, it starts down, ends up. So this part here is increasing from negative infinity to 0, and this part here from down it goes up forever. So also this one, it's also increasing. Okay, it's from negative infinity to 0. From 0 to positive infinity. So also this one is increasing from 0 to positive infinity. Why 0? Because the 0 is here. So from 0 from left to right, so positive infinity. Okay, so there is no decreasing for this function. I hope you understand this. Now, try to solve these equations, practice on them. I think now you are able to graph any radical or any power function. Now, let's go to the second part of the graphing, which is radical and exponential form. As you can see, we need to understand the radical function before we start. So the radical function is always depends on the index. Means if I have this one n, x to the power of m. Okay, so now what is n means? N here is the index. So the radical always depend on the index. And what is m here? This one here is the power, okay, power of radicand. Okay, what is the radicand? Radicand is the x, radicand. Okay, now this is the radical form. To convert this one to exponential form, so it should be when I have n, x to the power of m. So this one can be written as x m over n. As you can see, always the index in the denominator. The index in the denominator, don't forget. Okay, so this is the radical, this is the exponential. This is what you can see here. The exponential form, okay, this one. And the radical form is this one here. Okay, now let's learn how we can graph the radical and the exponential. Okay, as I told you, to know how to graph any radical function, the radical function, it's always looking to the index. Always look to the index, means index here, this number. So when n is even function, so the graph always is something when someone is swimming. Okay, and when the index here is odd, okay, so always someone is swimming and complete swimming to the other side and both sides. Okay, so this is the difference when the index is odd and the index is even. Okay, just keep it in your mind. You're not going to graph any difficult things. And as you can see here, when the power is odd function, it's negative infinity to positive infinity, the domain, and from negative infinity to positive infinity also the range, and the x-intercept is at 0, 0, and it's continuous from negative infinity to positive infinity and increasing from left to right, so from negative. So as you can see, always from negative infinity to infinity, negative infinity to infinity, negative infinity to infinity. So this one when I have a cube root, when I have index 5, when I have index 7, okay, so always like this. Okay, but when we're talking about the even function here, which is when I have a square root, when I have index 4, index 6, index 8, so always it starts from 0 to positive infinity. Okay, and the intercept is 0, and the continuous 0 to infinity and increasing from 0 to infinity, and we have only infinity part. So as you can see, when it's even, always it's 0 to infinity. Or I'm always telling to my students, it's always start from h to positive infinity, because you know that the formula of graphing the exponential, f of x a x minus h plus k. So always the domain start from h to positive infinity, and the range, so this is the domain, and the range always related to the y-axis, so it starts from k to positive infinity. Okay, so this is the domain and the range for the even, but for the odd, always from negative infinity to positive infinity, whatever the question will look like. Okay, now let's take this example here. Okay, now graph and analyze each function. Okay, my student, please don't bother yourself how you can graph the functions. This type of a question is coming like a multiple choice or choosing the correct graph. So don't bother yourself to learn how to graph exactly. Just do a sketch. If you know how to do sketching, okay, so that's enough for me. Now, how we can graph the first question here? So as you can see, x to the power 5 over 2. So now convert this one to exponential. So the radical. So it will be square root x to the power of 5. And you know that x to the power of 5 is what? What's the domain for the x to the power of 5? So it's a cube, it's like cubic function, so from negative infinity to where? To positive infinity. Now the square root, okay, when the index is square even, so the graph will start from where? From 0 to positive infinity, so the domain from 0 to positive infinity. Now which one is stronger? Is this one or this one here. Okay, so as you can see, always we take the restricted domain. So I know that the domain for this one is negative to a positive, but this one here, it's from 0 to positive. Okay, to positive infinity. So now when you need to graph your function, you have to take this restricted domain. You ignore the function that give you the whole correct domain. Always take the restricted one. Okay, so now the domain for the function should start from 0. So this is what you can do here. So always start from 0. And as you can see, the graph, okay, the graph for the cubic, or when the power is odd, it's going up like that. So you start from 0 and it's going up like this. So this is how you can graph it easily. Okay, so always keep it in your mind. Now you know how to identify the domain and range, because the domain from 0 to infinity and the range from 0 to infinity, because I don't have h or k, or h and k are zeros, the positive infinity. So all of these are, and this function is increasing because from left to right increasing. I hope this one is easy to you. Now how about this one here? Let's do it. So let's say this one is 6 over, let's convert it to exponential or fraction, x to the power 2 over 3. Or we can write it as 6 over 3x to the power of 2, right? So what is the domain now for 1 over x to the power of 2? What is the domain for 1x to the power of 2? So the domain for this one, it's x to the power of negative 2. So the graph for this, it's like this, right? So as you can see, there is restricted domain, which is the domains from negative infinity to 0 and union 0 to positive infinity, right? You know, sorry, positive infinity. Why is this one's not typing? Sorry. Okay, positive infinity. Okay, so this is the original function, which is if I take the function without the square root now, so it will be 6 over x to the power of 2. 6 is same as 1. It's a constant. So I can write it as 1 over x. So what is 1 over x? It's x to the power of negative 2. So the graph, it should be like this. Okay? So if you write... Now, this is the first function. This is the first one. Okay? Now, the second one is... Is this. So the second function is 1 over cube root of x. Okay? So now, cube root... What's the cube root domain? So you know that the cube root domain, the graph is look like this. So the domain from negative infinity to positive infinity. And as I told you, look now to the domain. Here I have restricted at 0. Okay, and here it's completed from negative to positive. And I told you we always look to what? To the restricted one. We just ignore this and we took only the restricted. And we ignore now this and we take the restricted. So because it's restricted, I'm going to graph this shape. So the graph of this function will be like this one here. Why the graph will be like this one here? Because it's restricted from negative infinity to 0 and from 0 to positive infinity. So this is how you can graph it. Now let's analyze it. So the domain, it's always should be follow this one. So from negative infinity to 0, union from 0 to positive infinity. Now the range from the lowest point. What's the lowest point here? The lowest point is 0 to what's the highest point? To positive infinity. Now what is the end behavior? So the end behavior when x approach positive, okay, it's approaching what? It's approaching 0. And when x approaching negative infinity, f of x is going where? Also is going 0. Always, I told you, when it's reciprocal, always f of x equals 0. Okay? Approaching 0. Now, how about the increasing, decreasing? So the first part here, from here going up. So this part here is increasing. So from negative, sorry, not negative infinity. Oh, sorry. From negative infinity to 0. Yes, that's right. Okay? And from up it goes down, so this one is decreasing. So decreasing start from 0 to positive infinity. Okay, I hope you understand this. Now we have here another type of questions to graph. So we do the same thing here. When we need to graph this one, I told you, you're not going to graph big functions like this. You need just to know small things about it. Okay. Now, if I need to know this one here, what makes the denominator here equal to 0? Okay? Or let's take this one first. Let's look to question number A. Okay? First, now I have here x to the power of 3. right? What is the graph for x to the power of 3? It's a cubic, so from negative infinity to positive infinity. Now the second function is the index 4, so x to the power index 4. So what is the graph when index is even, sorry. What's the graph when index is even? It's like this one here. So it starts from 0 to positive infinity. So as you can see here, which one is the stronger? Which domain should I take? I have to take the restricted one, so I have to ignore this one. So the graph will start from 0 and goes up like this one. Okay, then you identify the domain range. Now how about this one here? So this one, it has h, okay, and it has some stretching part. So if I need to know this one, okay, I have a common factor between 6x minus 8. So I can rewrite the question f of x is equal, okay, 1 over 4 root of 5. Okay, what's the common factor between 6 and 8 is 2. So 3x minus 4. Okay, so now this is the common factor. Now if I need to find the zeros, okay, if I need to find the zeros, which is make the denominator equal 0, because you know that this is, how many functions do we have here? We have two functions. The first function, which is under the square root, it's a linear, right? Because 6x minus 8 a linear. When I have x is a linear function, right? So what's the domain for the linear? From negative infinity to positive infinity. Now what is the second function? Is when index is 5. So x when index is 5. So when the index is odd number, the graph also from negative infinity to what? To positive infinity. So as you can see here, for the first function I don't have restricted domain. For the second one I don't have restricted domain. So as you can see, because I don't have the restricted domain for the first one and the second one, okay, so the graph will be continuous from the beginning to the end. Okay, so what should I do? So I will follow this one here. Okay, so because I will not follow the linear function, because always I'm following the stronger, and the stronger always has, let's say, the exponent or the root. Okay, so the root function, it's going like this. But now as you can see, I have h and k, so the graph, it will not be starting from 0 ending at 0 like this one. No, so it will be shifted to, as you can see, what is h and k here in this function? Okay, now forget 2, because 2 it's represent as 1 over b. This is 1 over b. But here this one, negative 4, represent by h. So take the opposite sign, always h. And do I have k? I don't have k, because plus 0, I don't have k, so k is 0. So now the function will start from 4 to 0. So 4 here, okay, and 0 here. So the graph will be like this. Okay, now what's the domain and the range? So from negative infinity to positive infinity. What's the range? Also from negative infinity to positive infinity. The x-intercept, okay, x-intercept is equal for y-intercept is, I don't have, I have y-intercept, but if you need to know the y-intercept, I have to replace x with 0. So if I replace x with 0, I will get y equals something. Okay, now then what else do I have? Okay, the increasing part. So the increasing, it start downs or going, so it's only increasing function. It's always negative infinity to positive infinity. Okay, I hope you understand this. Now I believe that you know how to solve these questions when you need to find the domain, okay, using the domain and restricted one. Okay, I hope you understand this.